DVCs to tell them this ecosystem that we will be developing that will allow us to work close to our community and our students to develop products that impact society. So that will be part of a specific focus we will have, and our research will not be research on a shelf somewhere in a library. We need to take that research further into products that actually make a difference. Ladies and gentlemen, research excellence does not happen by chance. It is built on curiosity, collaboration, and perseverance. It grows through mentorship, partnerships, and a shared determination to make a difference. That is why events like today are so important for us. They allow us to exchange ideas, to challenge one another, to showcase the outstanding work being done across all our departments. Therefore, as a faculty, we remain deeply committed to nurturing a vibrant, future-ready research culture, one that values excellence, integrity, and innovation. We take pride in the work of our researchers and our students, whose contributions are not only strengthening the academic profile of the faculty, but are also positioning TUT as a leader in applied research and technology innovation on the African continent. So let us have today's Research Day serve as a reminder that every paper presented here, every idea shared, every collaboration formed brings us closer to our collective vision to create knowledge that shapes a better, smarter, and more sustainable future. As we take part in today's program, let us be inspired to keep pushing the boundaries, to collaborate with courage, and to create lasting impact through our research and innovation. Once again, welcome to the ICT Faculty Research Day. May it be a rewarding and memorable experience to all of us. Kia liboga.
That was our Executive Dean of the Faculty of ICT, Dr. Etienne van Wyk. Thank you very much for that warm and inspiring opening and words of welcome. Thank you once again, Dr. Etienne, for really affirming that advanced technology frontier and empowering the community is key. This means that, colleagues, we should continue to participate in research excellence, produce quality research output that makes impact to the community and shapes the future. We truly appreciate your continued leadership, Executive Dean, Dr. Etienne van Wyk, and we really appreciate your support. Colleagues, we now move to the next item on the program, which is the highlight, or should I say one of the highlights on our program, the keynote address. It is my pleasure to introduce our keynote speaker, Dr. Amos Shibambu, who will be speaking on the topic Digital Transformation in the Public Sector, Opportunities and Challenges in the Fourth Industrial Revolution. Before we invite Dr. Shibambu to deliver the keynote address, allow me to share a brief background on our speaker, or of our speaker. Dr. Amos Shibambu is a senior lecturer at the University of South Africa, which he joined in August 2021. He holds a PhD in information science titled Digital Curation of Records in the Cloud to Support E-Government Services in South Africa. His PhD was awarded in 2020 by the University of South Africa. Dr. Shibambu is an alumnus of Tshwane University of Technology, where he obtained his master's degree in Business Information Systems titled Analysis of Information Technology Infrastructure Towards Improving Service in the Public Sector. His undergraduate qualifications were obtained from TUT while it was still Technikon Pretoria. He supervises master's and doctoral students, and prior to lecturing, Dr. Shibambo held management positions such as IT specialist, IT infrastructure and support service manager at the Office of the Military Ombud and the Department of Higher Education and Training. Dr. Shibambo research interest falls within Fourth Industrial Revolution, digital transformation, amongst others. He has published a number of research articles which can be accessed on his profile on Google Scholar. Dr. Shibambo also served as a reviewer for local and international research output. This is a scholar. Ladies and gentlemen, please join me in welcoming Dr. Shibambo to the podium. Dr. Shibambo, you're welcome.
Thank you, Program Director. Am I audible enough? Okay, thank you. Thank you to the Dean, Executive Dean, the second in charge. I'm referring to the Deputy Dean, head of the department, each and everyone who has made this day to become possible. I'm referring to the organizers and those who are still going to come to this podium and those who have come to support those who will be presenting. Once upon a time, I heard that in China, whenever they want to start a gathering, they start with a proverb. In Europe, America, they start with a quote. In Africa, they said, we start with the apologies. I did not hear any apology to show that someone is coming late or is still coming or has changed their mind, even though most of the seats are vacant. So as the program director has already indicated or explained who I am, indeed, I'm from the University of South Africa and I have been part and parcel of this university. This building was called Building 21 when I was here. I was called, when I arrived at the gate, they said to me, are you going to the New King? I said, I'm going to Building 21, the gray building that I know. So they said, no, it has changed. So things have been changing. Nothing has stopped. Things have been going on and on and on in this University of Technology. The title that I'm going to share with you as it is already reflecting on your program. It is digital transformation in the public sector, opportunities and challenges in the fourth industrial revolution. I will talk about the introduction, the definition of digital transformation, visibility of absent digital transformation, the aim of digital transformation, how to achieve it, factors that affect its achievement, what challenges it, overcoming the challenges, then I conclude. One thing that I have to tell you as I start with the introduction is that the illiterates of the 21st century will be those who cannot read and write, but those who cannot learn, unlearn, and relearn. The common wisdom of managing traditional organizations in the past is not sufficient to meet the demands of modern and digitally enabled organizations. The public services have traditionally relied on interpersonal relationships and manual operations for effective service delivery. When the COVID-19 came or emerged, it was an opportunity to accelerate the implementation of digital transformation. And indeed, some other places managed to show how to lead the way. Then after some time, it was changed. Things have gone back to normal. But during that time, we were told that it is a new normal. The new normal has now become the past. I don't understand why did we go back to where we used to be when we had a new normal. It highlighted how critical technology is supporting communities and driving economic progress when standard practices are challenged. The effects of the pandemic have altered how workplaces operate, and it has already also indicated how important it is to be responsive to technological integration to function even on the basic economic levels. Then this concept called digital transformation has got many definitions. It depends on where you stand. It depends on where you work, where you normally do your daily things. Others define it as the organization's wide shift that redesigns services through the integration of technologies. Others have said it is the use of digital technology to improve the quality and efficiency of public services provided by the government to the citizen. Others went on to say it is the digitalization of government activities, such as delivering a better and easier customer experience, enacting regulations that allow for a distributed workforce, upgrading and optimizing processes to save money and resources. Contextually, this entails rethinking core functions, workflows, and service delivery. Amongst the definitions that I have just read to you, any definition or any of them that is leaning too much on technology, it becomes a narrow definition because it is missing the practices and it also missed the culture that is required towards implementing digital transformation. I'm saying that because others still believe that once you have installed the software on the obsolete processes, you have now achieved digital transformation. It is not the case. You still need 99% of people and culture to be given attention. Then how do we notice that digital transformation is not existing or has not been given attention in the public sector? Most of the time, whenever you go around town, you notice long queues, sneaking around the buildings, or even stretching to other buildings. Those people are lining up to receive the service from the government department. Had digital transformation been implemented, I don't think the queue was going to be that much longer. Moving from one office to the other, looking for the signature. Imagine having to carry a paper from one department. They tell you that you must go to this department in order to get the signature and still come back here. Why can't there be another way to implement or to shorten that process in order to get someone to get assistance? It means for you to go to the government department or to get assistance for something that was supposed to take you maybe just 30 minutes, you're supposed to take leave so that you can be able to be assisted. And it is not guaranteed because the queue will be long, even if you arrive at 5 a.m. How many times did you hear that the dockets were lost at the police stations for something that had been reported, for something that is putting your life at risk? When you make a follow-up at the police station, they say, we're trying to find where your document is, or where your docket is. We can't find it. That shows that something is missing. You also realize it when the patient's records are misplaced. You will remember someone went to the public clinic in Soshanguve. After some few days, he got a call that he got a job and he will be working in Niger. Niger is at the far east of Ekurhuleni. And remember, when he went to Soshanguve Public Clinic, he was told to come back again next week. Now he is in Niger. Niger is now the disease has come back again, and he has not yet gone back to Soshanguve. Then he said, anyway, there is also a clinic right there. He went to that clinic to seek assistance. He said, I was in Soshanguve clinic last week, the other time, and I was supposed to go back for a follow-up as requested by the nurses. They said, no, we don't work like that. We're going to start over again. We need to know what is your problem. He said, the problem was this one. They said, it doesn't work like that. We don't have your record. We're going to start over again. So then, is that not going to lead to misdiagnosis of what this person was complaining about? He went there, and then again, he's still at the public clinic. He's not in a private clinic to seek assistance. That means, had the operations or the systems or the culture been changed, it was going to give them the ID number, and then they were going to retrieve what is required, taking it from the previous consultation. Duplication of patients' files in public healthcare facilities. Indeed, he has been to Soshanguve, now Niger. What will happen when he goes to Soweto? He's going to have a file in each and every hospital where he goes. Is that not wasting resources in that way? Resources in terms of money. How much does it cost to buy a file that has been for someone that already has a file in the clinics that he has been to? Loss of records at NARSA. NARSA, I'm referring to National Archives Records Services of South Africa. That is where each and every record from the government is kept. Can it continue to be kept in that way that they are doing when technology exists, when there's a need to change the practices and the culture? Then why do we need to have digital transformation in the public sector? We want to enhance public services and government administration. We want to prepare the government to face changes prompted by the advent of industrial revolution. I'm referring to the fourth and the fifth. We want to respond to the notion that the citizens expect a public service that is identical, that is identically responsive to the services provided by the private sector. Once upon a time, I heard that most of the private sectors depend on the government to get money so that they can run their projects. How can the private sector be so rich from the government to provide the service that actually is similar? We have got private health, private hospitals, private things that are happening. Some of them are funded by the public sector. Why is it so difficult for the government to proceed or to implement those services within itself, rather than to find itself putting more on and put the marginalized people at a disadvantage. To evade digital Darwinism and improve service delivery in a modern way. We want to uproot the Shakespearean dilemma, to be or not to be. We don't want to be standing on the fence. We want to wake up and go to the government department or government government institution to get assistance without any hesitation. That can be achieved through the digital transformation. Another aim is to demonstrate that the provision of public services is a critical function that bridges the gap between government and the citizen. To be the real interface between the government and the citizens. Through this layer, the citizens can tell if the government is serving them or not. By this, I'm trying to say the government itself has got 3 layers. We have got the local government, which we normally call a municipality. The municipality is the interface between the government and the citizens. If the municipality is not performing well, it's a true reflection that the government itself is not doing well. So while we have the current practices, it won't be easier to speak the good things about the government that we have in the meantime, because digital transformation was going to make it easier for us to recognize how things are going, where we are, and then in the near future we'll be able to do better. How can we achieve digital transformation in the public sector? If you were to imagine each and every government department operating like SARS, where would we be? SARS seems to have taken a good step that seems to outclass even some of the private sectors. We can achieve it by adopting a user-centric business strategy, by an ongoing process of adaptation, learning, innovation, and than a once-off project. This means digital transformation is not a once-off project. It's ongoing. It will be able to respond to any new technology that keeps on coming, and the culture will keep on improving. It will be easier for us to sustain whatever to sustain ourselves and face whatever is coming on our way. Digital transformation is achieved through critical reviews of existing policy frameworks and leadership that is capable to drive cultural and structural changes. The success of digital transformation strategies in any country relies heavily on the active participation and contribution of government employees. It needs capacity building, dedicated resources to ensure that the civil servants and the public benefit from improved services. What are the factors that affect digital transformation? IT leadership. I'm not referring to you. We're talking about the public sector. If the public sector has got the IT leadership that is not well informed about IT, do not expect anything new to come. They only become happy when they can receive their emails. They become happy when they can browse internet. That is the end of the story between them and their leadership style. Organizational structure, IT infrastructure. When you look at their IT infrastructure, most of the complaints will be that our infrastructure is old, but the IT leadership has been there for some time, and maybe at some point they employed others who might have changed, but the bureaucracy towards change is not that easy or makes it difficult. Skilled manpower. Nowadays, we have got people who are well informed coming from this University of Technology. These students get there and end up being frustrated. Then they ask themselves, what is the reason of working in the IT within the public sector? Because I'm not given the space to implement what I think can do better. The political landscape. Every political party wants to prove a point. Even if there were little things that were going well in the previous administration, the new one wants to show his or her presence that things will be done in this way, not in that way, because that will lead to praising the previous administration. The regulatory framework. Now and then there's a complaint that the government is not performing well in terms of IT or ICT because of state information technology. I'm referring to SITA. Some of the things that make it difficult come from the regulatory framework, organizational culture. For the digital transformation to work effectively, the culture within the government sector should change. It can't work in a better way even if digital transformation were to be implemented tomorrow, because the culture itself needs to be changed. Some of the challenges that make it difficult to access digital transformation: severe financial constraints, lack of specialized skill sets, and internal resources necessary to design and implement. It fails when organizational changes are not well received, where the acceptance for new technologies and new business processes are low. Lack of or high cost of skilled labor in the market, poor IT infrastructure, unreliable supply chain, stringent regulations, and many more. Citizens with limited digital skills or access to digital technologies are disenfranchised. You cannot say you want to serve the community with the high-end technology while the people that are supposed to get that service are also struggling to have access or to use technology. Some of the challenges lead to the ad hoc projects rather than the long-term strategies within the public sector. If you check again at COVID, during COVID, the ad hoc projects were implemented. You will start working from home. These things will be easy for you to do. Then after that, that was ad hoc. After that, when they said, now we can mix, we went back to the same place. And then we can operate the way we used to do. Then we need to foster digital transformation in the public sector. I have already indicated that digital transformation relies 99% on people and culture. We need to bridge the gap between aspiration and action. It is not making any politician or any leader good to go there and say, we want to implement this year, even next year and the other year, without any action. There should be an action when we talk of change. Instill the favorable organizational culture. Leadership styles that can drive cultural and structural change are necessary when you want to foster digital transformation in the public sector. Appropriate human resource management practices. The value from IT investment is realized only when inter-organizational relationships are formed. Smooth relations and collaborations with suppliers, partners, and other stakeholders enable successful digital transformation. Some of the benefits of digital transformation in the public sector. It allows how and where employees perform their work while also reshaping how citizens receive government services. It is of the cognizant that the activities aligned with digital connectedness, the citizens, just like the public servants, need convenience to interact with the government. To facilitate access to services, increasing government transparency, accountability, and increasing the efficiency, effectiveness of public services. The use of technology in public services has the potential to improve service quality and efficiency. The agility factor requires for creative and innovative responsiveness to this technological advancement is lagging. Challenges to the community, those who are expected to receive the service. To become more innovative towards developing systems that will enhance digital transformation. To take us out of the current public services. I said the title here is Challenge to the IT Community. I'm referring to our IT students or those who are working on developing softwares or things that can help us. You need to become more innovative towards developing systems that will enhance digital transformation. You need to take us out of the current public services. The current tradition is not efficient. You need to help the government and the citizens see the public service differently. One of the key core functions of the public sector is to provide public service in the form of needs and the needs of the community. The challenge is up to you, the IT and upcoming IT employees or specialists that will be coming from this institution to make a good change. They will help us to overcome the challenges, promote the digital literacy or digital literate nation. We will also want to see the public-private sector, which expands to the far-flung areas. There are rural areas whereby even today, the government is unable to interact with them. But during the elections, there is no place that they cannot reach. But for now, it is so difficult. They say it's not easy. There's no road to get there. The roads get easier to access those people when it is time for the elections. It is evident that one of the greatest needs lies in the investment of skills upliftment and telecommunications infrastructure that support transparency and openness in the socio-institutional component of the fourth industrial revolution. I think that was the end of my presentation. Thank you so much for the attention that you gave to me.
Another round of applause for our keynote speaker, Dr. Shibambu. Thank you, Dr. Shibambu, for that insightful keynote address on digital transformation in the public sector. Colleagues, it is clear that we cannot come right when it comes to digital transformation if we do not pay attention to issues of culture, involving people, as well as infrastructure. As I was seated there, I had amongst the mentioned challenges was efficiencies on manual processes or due to manual processes, physical signing or endorsement. I just want to highlight that at least with us here at TUT, we had advanced when it comes to that. Dr. Shibambu, you have truly set a stage for meaningful reflection and discussion in digital transformation throughout the day. Colleagues, I request that we engage with Dr. Shibambu during break to embrace the moment to create some networks. And I believe that research projects and collaboration initiatives can emerge during that time. Moving to the next item, I think this is the moment that we have been waiting for. Oral presentations. Before I call upon our speakers, I just want to make an announcement. We have judges that will be evaluating our presenters. And the message to judges is that please do remember to, as you complete your score sheet, do remember to note the participant name, their topic, as well as your name at the end. With this item, we have lineup of 4 presenters before our poster viewing session at 12 p.m. Each presenter will be given 20 minutes, of which 15 minutes are allocated for presentation and 5 minutes for questions and answers. To begin our first session, please join me in welcoming Dr. C. Kose, who will be presenting on a topic, numeracy counts, addressing quantitative literacy in programming education for novice underprepared student in South Africa. Welcome, Dr. Kose. Colleagues, while Dr. Kose is preparing for the presentation, I just want to highlight that we are going to use the PC to project the presentation so that we can accommodate our online audience.
Okay, good morning, colleagues and friends, and especially thank you to my colleagues from the First Year and Foundation Unit that came to support us. We are actually 3 of the unit, I must brag a little bit. 3 of the 6 oral presentations come from the First Year and Foundation Unit. So just take note. We are going places. Okay. The eyes of the old woman. Okay. The topic of my conversation with you today is numeracy counts, addressing quantitative literacy in programming education for novice, underprepared students in South Africa. Now, this presentation is just a snippet of a larger study that I did for my PhD, and it just serves as a reminder that there are concerns about our students' preparedness for higher education and the academic challenges going with that. The topic of my PhD was a framework for teaching numeracy to novice, underprepared programming students at universities of technology in South Africa. Before I go into the formal stuff, look at that picture. Buy bulk and save. We all fall for that. Get 3 kilos of carrots for 46.99. But you can buy 2 kilos for 22 Rand. Okay. So it's 11 Rand a kilo times 3 is 33 Rand for 3 kilos. That's one small example of how important numeracy is in our daily lives. Now, it's very important to remember that numeracy and mathematics are not the same, but they're not separate. Numeracy forms part of mathematics. And mostly we refer to mathematics as being abstract and numeracy being contextual. And in programming education, it is very important. There are a lot of definitions for numeracy, but a plain and simple, it's working with money, recognizing units of time, measurements, how many kilometers per liter when you drive your car, etc., etc. You are exposed to numeracy on a daily basis. Now, there are more formal definitions, and I like this one because it's been coined by South Africans. So, quantitative literacy, also referred to as numeracy, that's interchangeable, is the ability to manage situations or solve problems in practice and involves responding to quantitative, which can be mathematical, statistical information that may be presented verbally, graphically, table form, symbolic form, and it requires the activation of a range of enabling knowledge, behaviors, and processes that can be observed when it's expressed in the form of communication, in written, oral, or visual mode. So this is a mouthful. The main thing is how we react and deal with quantitative information on a daily basis. Now, the lack of numeracy skills, is a global dilemma. We always think South Africa is so bad and so far behind, but it's a global problem. And governments and policymakers are made aware of this dilemma, and it's suggested by many of the bodies out there that numeracy should be integrated in all curricula. Now, you all know about the Sustainable Development Goals of the UN. Goal 4 refers to inclusive and equitable quality education to promote lifelong learning. Now, 4.6.1 of that goal refers to adults must have functional literacy and numeracy skills. That's a goal that they want to achieve for the world. Now, I want to go back. There are several bodies, as I said, that are doing large-scale assessments. I'm not going to put it up all here. You might have heard of the OECD, the Organization for Economic Cooperation and Development. And under their umbrella, they have PIAC and PISA. PIAC is the Program for International Assessment of Adult. Forget it. All these acronyms, I write it down, and then adult competencies. Okay. Where they assess worldwide people from 16 to 65 with numeracy and literacy and things like how you use technology, etc. And they interview people in all these countries in their native languages. And those studies have shown that there is a huge problem with numeracy levels right over the world. Now, PISA is another assessment that they use. It's a program for international student assessment where they assess 15-year-olds, so teenagers. What's their level of literacy, numeracy, etc., etc. Now, if you want more about that, I can give you my chapter for my PhD, and you're welcome to read that. It's interesting reading. Now, let's look at South Africa. You might have heard about TIMS, the Trends in Mathematics and Science Study. That's done every 4th year internationally. Now, in those 3 years, 2011, 2015, and 2019, South Africa was second last. And I must just mention as well, the evaluations are done for grade 4 and grade 8. But in South Africa, the grade 5 and grade 9 students write it because they couldn't cope. The grade 4s and 8s couldn't cope. And still, we are far behind the rest of the world. Now, that's on school level. Let's look at university level. At UCT, they have a Center for Educational Assessment, the CEA, manages the NBT, National Benchmark Tests. And I'm interested in the part QL, the quantitative literacy. There are 3 tests, the AL, academic literacy, QL, quantitative, and MAT for mathematics. Now, the mathematics and the mathematical literacy are contained in the QL, but the math is just mathematics. The QL test assesses the candidate's ability to solve problems in real context that is relevant to higher education while using basic quantitative information. This tests, these tests were developed to inform higher education institutions of what they should change and how they should support their students. Now, if you look at these stats, the QL results, this is countrywide, from 2015 to 2020, that red block, lower intermediate, upper intermediate, those are the students that typically come to us. And it shouts they need support. If you go deeper into the categories there. In 2020, 22, and 23, we were privileged enough to let our students write the NBTs under the auspices of a project at UCT. And the QL, look at that. Only 1%, or not even 1% of our students are proficient in numeracy or quantitative literacy. It's a bleak picture. Now, higher education curricula don't include numeracy. We at the unit try to. In our mathematics, we try to build it in, but it's very difficult to inform or tell people that it's important, convince people. So numeracy is essential for programming because it's context-specific, real-world problem solving. This is just a snippet from one of our sets of notes of our Java notes that we give our students to explain to you. If you have to calculate work hours, etc., you still need numeracy to understand that problem. And that's another one, calculate the phone call cost, etc. Now let's look at our students. Our first year students, they are novice, they're underprepared, they're programming students. A lot of them had inadequate schooling and very little or no ICT exposure. They're underprepared for higher education. I've mentioned that. And unfortunately, we deliver students from the school system with a lack of mathematical proficiency as well. We experience language barriers. And one of the biggest problems, lack of problem solving. Now, to address problem solving, we can add computational thinking in the mix, and to teach them numeracy and programming using computational thinking. Now, you're all familiar with computational thinking. I'm not going to go into details here. Now, this diagram is basically the summary, where it says computational thinking supports programming, it supports numeracy, but they all support each other in different ways. Because numeracy is embedded in programming, and if you are proficient in numeracy, it benefits your programming abilities. But, okay, what now? Ongoing research should be done, because I strongly believe we should incorporate numeracy in all faculties, not only in ICT. We must look at what do we teach. Focus on problem solving, then programming won't be difficult. How? We should use effective teaching strategies and pedagogy. When? As soon as possible, embedded in the first year. And who do we teach? In our faculty, we have the novice underprepared students. So in closing, we must teach our novice programming students to build a strong foundation for critical thinking and application in real-world scenarios across all modules. It is something that we cannot ignore, and it's something that we need to take cognizance of every day. Thank you.
A round of applause. Thank you, Dr. Gutse, for the insightful presentation on numeracy counts, and also highlighting that this research addresses global societal challenges. And it's also good to note that your research aligns with the global agenda and contribute to the Sustainable Development Goal. Colleagues, we will now take a few questions from the audience. But before we go there, may I kindly request that we keep our questions clear and concise so that we can make the most of the discussion time. Any questions from the floor? Okay, any roaming mic?
Thanks, roaming mic man, Walter. Thanks, Carla. I think all of this also links up to our admission requirements. I just shared with the Exco earlier that I'm currently looking at how our students, the students who pass programming the first time, what their maths mark was at school, because we are currently using that as our indicator of numeracy levels, problem-solving ability, as the sole indicator, actually, in our admission requirements. It's a cold indicator, your school maths mark, and we already know all the things that happens in terms of school maths marks. And there doesn't seem to be a correlation in terms of your maths mark. Actually, the people that had a 7 in maths, less of them passed programming the first time than those who had a 4. That's currently what I'm seeing. So maybe I just want your opinion on what you've done also in terms of your studies for your doctorate. What should we look at in terms of a more scientific approach to our admission requirements rather than just taking a school maths mark, if possible?
Okay, I did not focus on that as a part of the study. I used the problems that we get and said what we must do in terms of in class. I didn't fix that. I didn't look at that admission part, but it's a valid point, and that's why the NBTs came into existence in 2005, because of the sort of trustworthiness of the matric results. Because we found in the unit that students with mathematical literacy sometimes do much better than the students with maths, pure maths, because they are used to problem solving in stories, words. And that's what we focus on for programming. So I also thought we could look at a study go a few years back with secondary data and compare how they did the math versus the math literacy. There are challenges for the math literacy students the moment we get to fancy algebra, but they pick it up. But I don't know. There's not a clear answer. We should do research and determine a profile for a typical programming or ICT student, and then maybe even develop our own test, but that's a big one. The NBTs are a nice indicator because they look at academic literacy, that's language, English, the QL, which is problem solving. I'm not too maths one because that's focusing on pure maths. And I don't think our students really need fancy pure maths. They need problem solving. And that can be taught with Mathlit. But unfortunately, the way the subjects are offered in school is not problem-solving based. I used to do a lot of extra maths classes for high school kids. The teachers teach them little recipes. They never learn to solve problems. So the guy with a 7, The one with the 4 can't remember a recipe, so they had to try to solve this problem. So I'm not very popular at high schools in my area when I say they're not teaching maths properly. Go and tell your teacher that's wrong. My juffrou sê, Tannie is verkeerd. My teacher says you are wrong. So I like to focus on, for my master's, I did mathematical thinking for programming. Now that's also part of the mix. I don't know what the answer is. If you've more research required, I'm willing to something. Who's going to help me? Who's on board? Thank you.
Thank you very much and for that important question, and Dr. Koseu for your response. I think indeed this requires, or it's an opportunity to extend on this particular research, as we are all aware that we are in a business of knowledge production. Do we have another question just before we? Okay. Just be brief so that we can move to the next item. Thank you very much.
Yes, I'll be brief. Thank you. How did you conceptualize the unpreparedness in your study? Because you talk about unpreparedness. How did you conceptualize that? Thank you.
Okay, we looked at the NVT results. We looked at what the literature say about first-year programming students worldwide. And I also did soft systems methodology with focus groups, etc., with students. So and we deal with them every day in the unit. So that's a lot of that is experience, but I looked at it from the research side as well. Thank you.
Another round of applause for Dr. Kotze. Thank you, colleagues. We now move to the next presenter, and we will be joined by Mr. G. Muyeti on a title, Smart Surveillance System for Real-Time Monitoring on Farming Environment. Let's give Mr. Muyeti a warm round of applause as we invite him to the podium.
Thank you, Chair. And good morning, everyone. Are you well? Sorry. Thank you. Yeah, I think it's okay.
Is the presenter audible enough?
Hello, can you hear me? Awesome. Good morning once again. The topic or the title for my presentation this morning is as follows: Bimodal Smart Surveillance System for Real-Time Monitoring of Farm Environments. Okay, my name is Glenn Chonolo Mwepi, and I'm currently registered for my doctoral in computing from the Information Technology Department under the Faculty of ICT. My main supervisor is Prof. Topside Matonzi, and co-supervisors are Prof. Duplessis, Dr. Mushenje, and Dr. Titi. With that said, guys, I just want to give you a disclaimer. This presentation will be offered in sport mode because there's so much to share, yet so little time, okay? So bear with me. So this is the overlay or the overview of how the presentation is structured. I'm gonna be discussing the background, the problem statement, the research questions, related work, methodology, system architecture, development, and implementation, results and findings, significance of the study, recommendations and future work, and concluding with the bibliography of the cited and uncited researchers in my work, hence the bibliography instead of the reference list. So with regards to this study, we are aware that farm invasions, farm murders, livestock thefts, and vandalism of critical infrastructures is rampant in South Africa. And this creates threats to farmers and, of course, the food security and the overall economy, as in line with the faculty's group guiding project. So our food security is being threatened, guys, okay? So with this research, we are able to solve part of some of the threats that are faced by our farmers. So the picture behind me depicts a farmer tax in South Africa from 2023 to 2024. You can see that definitely there has been a substantial decline. In January to October 2023 and 2024, the numbers dropped down from 155 to 114. And the farm matters, of course, dropped down from 42 to 26. And with that said, some people may argue that, hey, but there is a decline. But the truth is, this still paints a very gory picture. Farmer attacks are rampant, and we need to come up with innovative solutions to curb this plague. Moving on, I'm sure you know this infamous picture, right? Hello? You've seen this picture before, right? Yes, this picture was worldwide circulated, even though it was accompanied by unqualified data, and of course, misleading truth. But the matter of fact is that farm attacks are rampant in South Africa. One life lost is one too many. Moving down, even though there are problems, farm attacks issues, we find that some farmers, they've already come up with ways to mitigate the farm attack problems or issues. They have employed surveillance systems in their farm or in their environments. However, the implemented system, they still suffer from certain limitations, and some of the limitations include the blind spots in large complex, a reduced effectiveness in adverse conditions, false alarm triggered by wildlife or event that's unentertaining. And then, of course, most of the employed systems, they rely heavily on unimodal biometrics. And we all know that once you start using unimodal biometric, it simply means that your system will be susceptible to spoofing, presentation attacks, data noise, and of course, they will increase in false acceptance and rejection rates. And lastly, most farms, they are located in the rural areas. And with that said, we know that the rural areas are prone to lack of reliable high-speed internet connectivity and lack of communication infrastructures. And this poses significant challenges in deploying real-time systems. And of course, issues like device heterogeneity and interoperability and constrained edge resources also contributes to the limitations and the complexity of having on-site analytics. So the research questions are outlined. However, the main one is how to go about developing an intelligence surveillance system to improve on the farm security. And then sub-questions are, okay, there's a feedback, do you mind? Thank you, muting. Yeah. Okay, thank you. Yeah, and some of the sub-questions include what are the limitations of the existing surveillance systems in detecting and identifying authorized people? How can the proposed surveillance system be designed and implemented to improve farm security? And of course, at the end of the day, its effectiveness. How are we going to be evaluating the effectiveness? And these questions relate to our objectives to identify, analyze all the limitations, and design a system and implement a system that will be able to solve such pertinent issues that we have already outlined. And of course, we have synthesized many research related works were synthesized, and I have categorized the related work under 3 categories. Category 1 is the computer vision approach, whereby we have said et al. They develop a system that can solve the problems I've just explained to you. However, in them using the CNN and the LSTM model for anomaly detection, their system struggled with noise and low resolution feeds. And because the system that are eminent or that are mostly out there, they rely heavily on high quality visual data and lack robustness in noisy or low light or real world surveillance conditions. Furthermore, under category 2, which is the hardware dependent systems, some of the systems available there, they rely heavily on hardware, on wearables, and are hardware dependent systems, and they are costly, they are intrusive, and they're difficult to maintain and not scalable to public or large area deployment. As asserted by Lee et al., they developed a system that used a camera, a microphone, pressure sensors, and of course the system came at a high cost and complex in terms of maintenance. And lastly, category 3, under the related work with regards to the solution, we found that most systems, they do rely on unimodal. However, there are systems that were developed by other researchers that used bimodal systems, and Hu et al. In 2024, they had one that uses palm, vein, and the face. But again, the system required close proximity for your palm to be scanned. And then, of course, it limits the use of the system in public wide area space. So with that regard, our key innovation is that we wanted to develop a system that will use biometric surveillances that are non-intrusive, and of course, fusing with existing infrastructure, eliminating hardware dependencies, and moving to maintaining the accuracy across different environmental conditions in farm environment. So the methodology is following the design science approach. System development, obviously, it's the deep learning computer vision model, the YOLO V version 8 CNN COCO SSD. And then, of course, for experimentation purposes, we built 2 non-intrusive bimodal lightweight surveillance system prototypes for real-time object detection using facial and the gait. Gait, guys, refers to the movement or your skeletal or your pose, guys, okay, of animals or human beings. So all this was built with Plataflow, Python, OpenCV, Tensor. So each system has its own characteristics. So, and they were on IoT, cloud, and edge computing databases employed the backend. We used MongoDB and Firebase for Prototype A. And the performance metrics that we were looking for measuring the system, we relied on the speed, accuracy, F1 score, and the confidence. And then from there, this is the holistic DNA or blueprint of the system architecture. It's complicated. For ease of manageability, I have cascaded down here, whereby you have the administrator console and dashboard, the user interface. After the logging in, of course, the cameras will be there. We use the Hikvision cameras, and we'll have people or animal being captured by the live camera feeds. And then from there, the camera will what? Using the Boolean logic evaluation, either 0 or 1. If you're matching 1, you get 1. If none of the biometric signatures are a match, the system will decide that no, indeed, it's a 0-0. That's an anomaly that has been detected. So, and then an alarm will be raised, an alert will be sent to the administrator. So mostly the system is detecting the humans, like intruders, like to try to avert issues of farm intrusions. So as described, prototype A, YOLO V8, and then the process is similar. That you initiate the security system, and then stage 2, data acquisition. That's where the image or videos are captured. And then we have the pre-processing. We apply the image enhancement because images are prone to data noise. And of course, the recognition module, whereby the gait or the face or the templates are going to be checked. Do I have this face in my database? If not, then it's a 0. Do I have this? Then it's a 1. Based on the 0 on the Boolean or expressions, then a decision will be made and an alert will be given if it's warranted. If not, if it's a normal event, then there won't be alerts. So on the left-hand side, you can see that, hey, the prototype A, it was built on YOLO V8, and then on the Flutterflow, Firebase, and some of the GitHub APIs for movement detection and face detection. There's many models that were considered, and others were used, and others were tested, but they did not meet the end product. And prototype B, it's a high fidelity prototype. DSK in programming language or Pythoning was used. And then unlike the CNN, it uses single shot multi-box, whereby one shot, the object will be what? Will be identified and given a class, or the class will be determined. With CNN, YOLO V8, same thing, single stage model, one shot, and then object detection is done and it's also classified. These models or these frameworks are supervised learning, and they are very fast and accurate when it comes to object detection and classifying. So the COCO SSD model also rely on the KNN, neighbors. If there's a picture or an image that is not aware of, or it's not in the local database, as shown here at the bottom of the structure on MongoDB and local machine, if the image is not there, it knocks next door, knock, knock, nearest neighbor. Do you know this picture? And then from there, if the picture is known, then the feed is sent back. With CNN, obviously they use neural networks, thousands of databases, millions of pictures. So if there's an image or picture that is not clear or the system doesn't understand, it will start checking the picture using the neural networks. And then from there, for this system, obviously, with any machine learning application, you need to train your data sources. So TensorFlow frameworks, Google Colab, we use RoboFlow 100. There were millions of public data that are employed in the system. After you have trained your data, now you need to pre-process, you need to fine-tune, and there's millions of techniques out there. You just have to find whatever that works for you. And of course, there's adulteration. Did you know that data also goes process of adulteration? And augmentation, and then flipping, changing the pictures, cropping, making sure that through the training of the data, different angles are covered to improve the accuracy or the detection of whatever pictures or images the system will be detecting. So they were applied over 15 training epoch. Epoch, it's simple, in simple machine language, is the number of, in terms of, okay, fine, my time is about to be up. So basically, now the field experimentation, the systems were put into the test, prototype A, prototype B, and prototype C. We introduce a baseline for benchmarking YOLO V8. And then in this instance, in the current environment detection, we have results. In multiple object deductions, results are there to see. We have dark environments, prototype A, B. They were lagging. Prototype C, with the YOLO one, was advanced, could even detect, animals at the background. And then close up, we've got all the system doing their job. At the end of the day, when we are looking for the critical matrices, the accuracy, the speed, and the F1 score, we ended up here. SMS sending here, we ended up with all the results. The F1 score under dark environment with infrared enabled, without infrared, in crowded, in close-up, in wildlife, in low light, all the systems performed. The YOLO V8 system or the prototype C, which is a state-of-the-art, outperform all the build prototypes. But with that said, prototype B was right behind prototype C, which is the YOLO, and with a few refinements, with more data trainings, and prototype B will definitely catch up with YOLO. You know, YOLO is a state-of-the-art. This has been there for a long time. So these are the table of results. Everything red, it simply means the system was underperforming. The YOLO is prototype B, which means that the system can be used. Somewhere it was scoring 74%, just 86% after the YOLO. And then at the end of the day, more greens for YOLO and more yellows for the prototype B. And then from there, limitations included misidentification in current scene. Some people were not detected. And at the end of the day, contribution to the study, I have demonstrated that we can use AI for smart surveillance, and of course, multimodal biometrics can be incorporated in our normal surveillances. So for practicality, we should allow farmers, we should enable farmers to adopt such innovations so that they can improve their safety. And then, further fine-tuning, further training, and of course, STEAM can adapt to different scenarios and different applications. With that said, thank you for listening.
Thank you very much, Mr. Moapi, for that thought-provoking presentation on smart surveillance system for real-time monitoring of farming environment. Colleagues, we will now take questions from the floor. Maybe by the show of hand, let's see who has questions. Just for the... Okay, can we have a mic? Okay, you can start with him so that we can close that chapter.
Thank you very much. The presentation was very much decorated and very much interesting. I'm very much interested. You see, there are points that which I've missed. During your presentation, I was sort of sleeping at a certain corner. In fact, needed to detect a research gap. A research gap is an area or a topic where an information is lacking, outdated, limited, or inconsistent, and where further investigation is needed. So I needed to perhaps check that when you come up with this, which gap perhaps you've identified. Because in as far as I understand that a research will never begin if perhaps there's a gap. There's no gap. Once you begin with the research when there's no gap, it means that there was no necessary that perhaps that particular research was supposed to have been undertaken. Thank you very much.
Thank you, Dr. Matangu. I would like to allude to the fact that you did say you were asleep, and I forgive you. Moving on, I have categorically emphasized that the gaps were actually, segmented into three. We have the computer vision approaches whereby there are gaps, and the system rely heavily on high quality visuals, and you find that there are occlusions, right? There are, in terms of different or adverse weather environments, the system, those CCTV that are in place, they suffer in terms of detection and object identification. And the second gap I've highlighted was that most of these current systems, they are heavily reliant on what? On the wearables, on the devices, on the RFID, on the base station. So in these instances, you are striving for a system that eliminates all such complexities, and of course, it will translate in money being saved, you understand? And the third one was most of the system that you are aware of, they rely on the facial signature, right? So this one, I have designed it actually relying also on the gait, the movement, the pose, and the skeleton, so that when you move, the system can say, "Oh, but is that Mr. Matangu?" Like in this picture. Let me
Thank you very much, Mr. Mwepi. I think we've run out of time to demonstrate further. Thank you very much. You can ask a question, ma'am. Thank you.
Thank you, Mr. Mo. Happy. Your study was quite insightful and very much broad. So I just wanted to ask for clarity. In one of your listed challenges, you've mentioned the issue of network infrastructure. So with the proposed systems that you come up with, how is it going to be able to be utilized with regards to the network infrastructure that you've mentioned? I just want clarity regarding that. How can we implement it, knowing that we still have network infrastructure in our rural areas? Thank you.
Okay, thank you for the question, ma'am. Yes, we know internet connectivity and infrastructure is a pertinent issue, especially in rural areas. But then this system, as I have earmarked, is that in terms of, it will be IoT based. It will use internet, of course. And then, of course, we'll have a database on the local machine so that all the data sets of the animals, the employees, they can be saved local on the PC, right? And in terms of, let's say, images of wildlife, images of people that are not in the database, or things that the system is not familiar with, then the system will trigger what is called and what is known as edge computing. Like we're bringing the analytics closer to the system, right? And then if edge fails, then the system will try to incorporate the cloud computing network. So it's a three phase. If A fail, if I don't have the information here, then I check next door. on the mid-range cloud server, right? That is our edge, closer to the network, okay? And then from there, if the edge fails, that's when the system will start trying to use or being deployed worldwide to find solutions to whatever image or whatever picture that may have been taken. So that's how we are resolving the issue of network latency and unreliable internet connectivity. Thank you.
Thank you, Mr. Mwapi. You can just, for just a few seconds, you still want to ask a question, sir? And please just be brief. I know you're very good at
No, I
brief.
just wanted to make a comment, almost like a recommendation that maybe you should think about packaging the solution such that it can be commercialized, such that it can actually be used. Yeah, I think it would be very good. Thank you.
Thank you. We have already applied for patenting the system.
Thank you very much, colleagues. And now we're going to move to our third presenter, which is Mrs. Ntuli, on a title, Optimizing Spectrum Utilization in Wide Space Networks, a real-time framework for interference mitigation and management. Welcome, Mrs. Ntuli. Colleagues, if you still want to engage on the presentation for the previous presenter, may I kindly request that we continue the conversation during lunchtime. Thank you very much.
Good morning, colleagues. The Office of the Dean, especially my colleagues in the unit, Sanbona. As I was sitting thinking of how to explain my study or this project in a simpler way, I then come up with a few scenarios that will at least give a background of the study that I've done. I'm not sure, Tumelo. Okay, sorry about that. As I was fine-tuning my slides. Okay, my topic on the program and on my slides but it's the same project. Okay, back to the scenario. On foundation, we have more than 1,000 students. Let's say those 1,000 students, all of them with their phones, with their laptop, with their tablets, they log in either on Brightspace or on my tutor. It means that now there's a demand, a growing demand into the spectrum. Now, we have a normal way of doing things when we're planning the network, a static traditional way in planning the network, meaning in Soshanguve Building 10, this network that will be required will be more than the network or the frequency bands that will be required in Building 12, where our offices are. Now, should we say all our 1,006 or 1,002 students log in, we are saying we are now congesting the spectrum. While in Building 12, the spectrum is relaxed, is free. While now let's say students are trying to write a test on Brightspace, now the system will start to buffer or will start to be slow or will start to kick others out. And in our office, we have enough spectrum that we can allocate to Building 10. So the project is all about now moving the spectrum intelligently so where the needs arise with the artificial intelligent hybrid systems that we have identified. I'll take you through the project that we've done with CSIR. It's a project that partly finished. My part on the project is focusing now on the interference part, where now we are saying, while we are dealing with a growing demand of the spectrum congestion, how can we then mitigate the interference? That's how the motivation of the study came from. And then we saw a need to have an IA-based dynamic spectrum management, where we aimed with this project, we aimed to use real-time data and machine learning to really optimize how we use the spectrum equally so. Now, the problem of the project was seeing how static allocation is on the underutilized and congested bands, and the need for the increase in the interference while it degrades the quality of service with the user, and the lack of real-time decision-making in the spectrum assignment. Then the objective of the study was we needed to develop an intelligent framework that will enhance the utilization of the spectrum while we reduce the interference and we improve the quality of service. I think I just gave you a background, but then a gap of the study, we saw a need, or we said, then we needed to come up with a hybrid system that will use intelligent learning to adopt the real-time data while it used the rule-based safeguard measures into making sure that we use the spectrum reliably. So the framework overflow, it used combination of machine learning agents, deep reinforcement learning, and multi-agent systems. Then it will work with the geolocation spectrum database that is already there. It's running at CSIR, and the software-defined radios already are developed for spectrum sensing and data collection. And then we adopt, the system will adopt dynamically to allocate and avoid the interference. Now, the flow of the system, it has an input where now we have, it will make sure that the spectrum, it will sense where the spectrum is not in use. Then it will map up the interference from the sensors and the database and the software radio devices. Then it will use optimally the engines where it becomes, machine learning becomes the heart of the framework. Then it will then tells us on which spectrum, or it will allocate where the spectrum is needed on the radios and the devices. Then because it has machine learning, then it will loop while learning from the previous data. So this is the framework that we use. The sensors are there. The software-defined radio is there. The geolocation spectrum database is there. It's working fine. Now, what we are coming to do with this project, we are saying, when more devices are into the network, usually there's an interference. Then how are we mitigating that interference? Now, with this framework, we have now the multi-agent with the machine learning modules that have that becomes the heart of the framework, where we have a spectrum prediction and pattern recognition, where it analyzes the large volume of data in real time. Then it will detect all the active and inactive frequencies. Then it will recognize the patterns, then predict when and where the spectrum is idling and in use. Then it will go to detecting the interference and trying to mitigate, where it will identify the interference by learning the characteristics of the unauthorized and authorized users. Then it will go to the third block, where we will now dynamically allocate the spectrum by using the reinforcement learning. Then it will learn how to allocate spectrum dynamically. Then it will come to the red block, where the performance and the monitoring, it will continuously improving. Then it will loop again in making sure that the performance, it is continuously monitored on the system. Then the metric that we have concentrated on is the throughput, the latency, the packet loss on the network, the quality of the signal. Then it will give us the feedback and the update on the internal modules, in making sure that the smooth operation improves and it loops up until it improves itself, since it has machine learning agents in. Now the simulation setup, is the data is from CSIR with all the trials that they have been collecting, doing around the country, in making sure that we have the white space in all the, most of the time, I know that in building, here in building 21 and building 31, we have the sensors from CSIR that collects the white space. Then our students use the white space for the internet instead of using EduRoam or net telecom or MTN as the service provider. So they use the white space as the mode of getting into the internet. And then we have simulated environment in the labs, where it is controlled and with the project was repeatedly, so that we have the results that is needed. And then we used Python, NumPy, Pandas, Matplotlib, amongst other libraries. And then, as you see on that picture, our test bed, we had all the wireless environment that are in at CSIR. And then we have the software-defined radio that works together with the geolocation spectrum database with the software called MQTT. And then we have now the dynamic spectrum allocation, where we'll make sure that the framework integrates the sensors with the defined radios, with all the artificial intelligent models, with the geolocation database to enable the real-time interference to free the spectrum management. So this is the interface, how it looks like on the software-defined radios that is running at CSIR. So this framework was tested with this defined radio in making sure that we target places where there's interference, and then we fine-tune it up until we saw that it can make an impact and mitigate interference. So these are the list of channels that ICASA gave CSIR to use, or South Africa to use. But then on those ones, we've just used channel 25, 26, 27, and 36, where we saw that on 2 channels there was interference, and then we did our testing, our simulation in 30 minutes duration. And then while we were looking at the spectrum utilization efficiency, we're looking at interference mitigation rate, we're looking at throughput and the latency. We have made sure that where there's too many primary users, the framework, it does It checks if the system can safely share spectrum without causing any interference. And then we had scenario B, where extra users join and leave quickly. That tests if the system can keep good speed and fair access for everyone. Scenario C, we had some users need fast response while others, they don't. Then we saw that the spectrum utilization was improved by 35%. The interference reduction was at 42%. The latency was at 28%. The packet loss was on 31%. Now, as the number of devices grow, the interference level increased gradually, reflecting low interference as the network scales, and then per device slightly decreased as more devices were added. Almost in conclusion, then the framework helped the network to work faster and more smoothly by checking the frequencies where they were busy and switching to a clearer one. The real-time spectrum optimization framework improved on how the availability of spectrum were used. The network also became more stable with fewer dropped connection or interruptions. Now, the pillars of contribution we contributed in the AI-driven framework. We demonstrated that the DRL-based interference can be mitigated, and then with the integrated of collected data, this project was able to function. And then we have an addendum in our project that has a proposed policy guidelines for dynamic allocation. So the limitations were most projects, they don't use the real-time data, where in our future work, we would love to see larger network scaling using the multi-agent coordination with the framework. Now, in conclusion, we've seen the improvement in overall bandwidth utilization, an improvement in the effective bandwidth per user. We've seen an improvement with the throughput and the spectrum efficiency. With the quality of service per parameter, we've seen an improvement in the latency, the packet loss, the jitter, and the network availability. With this data at CSIR, and I'm proud to be part of this big project because it's one of the projects that when you see your device not buffering, it will be because of frameworks like this project. Thank you.
Thank you very much. Another round of applause for Mrs. Ntuli. Thank you, Mrs. Ntuli, for that informative and stimulating presentation on optimizing spectrum utilization in wide space networks, a real-time framework for interference mitigation and management. Colleagues, we will now allow questions from the audience. Can we now prioritize our audience online? Can one of the organizing members assist in accessing the question from the audience online? Okay. It seems like we have no questions from online. And now this gives us an opportunity to ask questions from the floor. Any questions? One gentleman, the other question. Okay.
In fact, this is not a question, it's just a comment to what the ladies presented. I think it will solve much of our problems. And as much as you refer to it as from building to building at a particular campus. So I wish in future it could be extended to campuses, for instance, that sharing, because it's more about sharing, which is caring, in terms of when there is a lot of bandwidth that is utilized for Pretoria campus, other campuses which are not highly involved and active that could be shared as well. So it will minimize a lot of hiccups that we are coming across, especially when we always have the problem, students writing a test, the system is very slow, and sometimes it eventually lead to the situation where some tests are cancelled because of that. So academically, it will help a lot, and I wish that it could be elaborated further in future. Thank you.
Thank you, Plaki.
Thank you very much for that contribution. Moving to the next. Okay.
Yeah, thank you for the nice presentation. It's really indeed a good work. But I want to draw your attention to a term you have been using here, which is a spectrum. I think you need to look into that critically, because the spectrum you're using there is the spectrum actually refers to different sections of the electromagnetic waves. So, and I believe this work is basically a wireless communication. So specifically, you're working on microwave and radio wave. So what you're managing here is the bandwidth, dynamic allocation of bandwidth. So please look at that and change the word to spectrum. Thank you.
Thank you so much. Spot on.
Thank you very much. It seems like today we have, or with regard to the speaker, we only have contributions. Any questions, colleagues? Okay.
Thank you very much. You deserve a round of an applause. However, it is fine. This is a good presentation, Mantuli. Now, you see this technology, I'm not so clued up with it, but then now I in fact wanted to check as to what algorithm can improve spectrum allocation efficiency in an environment with limited availability.
Lucky, we have what we called a white space. As the gentleman has said, it's not a spectrum, it's a frequency band. So, yes. So on a frequency, if all of us can use our cell phones now, we'll have an allocation on a frequency band. So what happens to where there's no usage? So my system says we can then allocate those free to where the need is. So, okay. Thank you, Doug.
Thank you very much, colleagues, and yeah, well done to our presenter. We are going to move to the last speaker of our first session on oral presentation. The speaker is Mr. B.D. Mahlangu on a titled Early Behavioral Cattle Health Detection Model using Deep Learning and Body Area Sensors. Help me welcome the speaker to the podium, colleagues.
Morning, colleagues and gentlemen and everyone. My name is Derek Mahlangu, a first-year master's student in computer science. And I'm honored to be among the first group of doctoral candidates who were presenting where I am now. Yeah. Yeah. But I hope I'll pull through. So my topic of my research is an early cattle health detection model uh, using deep learning and body area sensors. So basically, what I'm trying to research about, it's a model that will detect the health in cattle in real time, basically. So my first lighting background, I'm explaining more on the cruciality of livestock farming in the rural economy, and also how the farmers are having challenges in this emerging the ones the farmers who are emerging in livestock farming, basically with the challenges that they are facing is the disease diagnosis and the outbreak and the veterinary access, basically due to the lack of real-time monitoring model that is not there yet. Because usually what I've noticed or picked up when I was doing my research is that the current methods, basically they only rely on the visual inspection once, while let's say a farmer or anyone who take care of the cattle will have to come in the morning to the kraal and check the cattle, and by then you'll find that one cattle during midnight had some complications, and they will only realize it later in the morning when he comes to check the cattle. So that's delay, basically it leads to an economic loss in the rural, because of they won't be able to produce the productivity, the trades, and increase, and also the increase of of cattle mortality. It rises basically because of there's no model currently that's working on detecting cattle health in real time, or at a prompt response, basically, if I can say that. So sorry about that. My research problem is that usually what happens is that current livestock monitoring systems that are there, basically they only focuses on deep learning. You find one researcher is focusing only on deep learning, other is focusing on the IoT sensors, or other is focusing on edge computing independently. And also that there is no integration or basically of real-time cattle detection framework that incorporates these three technologies that I'm referring to, the deep learning, IoT sensors, and edge computing, so that it can make farmers, the rural farmers' life more easier. So the research basically is proposing that to combine this technology into a unified real-time cattle health detection framework that will also sustain, or that will be also suitable for smallholder farmers in the rural. My research questions. So I'll just outline my main research question, and it stands as follow. It says, how can an early cattle health detection model be developed that can integrate deep learning, wearable body area sensors, edge computing to provide real-time personalized and context-specific health monitoring, particularly in the emergent farmers in the rural in South Africa? And the research goal is that I want to develop and validate an end-to-end low latency edge computing framework powered by deep learning, body area sensors, and the accurate and early detection cattle health anomalies and in South Africa farming environment. So these are also the limitations that are currently there when I was doing my when I was checking also on my research goals, objectives, and the literatures, that data scarcity and also hardware and cost and connectivity in the rurals. You'll find most of the farmers are just depending on those livestock farming. So if they don't have that model that will assist them to detect early health thingy model in their livestock. It becomes a challenge also. So with my literature review, I'll be focusing more on outlining what is precision livestock farming, where I check on the sensors that the researchers have used, monitors that monitors and data analytics to monitor individual health and welfare. And I'll also be checking on the body area sensor. So basically, these are my research concept themes. As precision livestock farming and body area sensors, deep learning and edge computing. And an overview of related literature is that is deep learning for disease detection, which now studies shows that there are high accuracy in recognizing specific diseases. And also with edge is that the intent of shifting away from centralized cloud processing is because of the cost and also the connectivity issue. So integrating these three technologies in together will also assess challenges, livestock diseases management and biosecurity weaknesses in South Africa, emphasizing the need for us to robust and accessible and automated solution to protect the sector and the trade in the rural areas. The methodology will be using the design science approach, bringing and AI and edge computing, where I will be addressing the core precision livestock farming scalability challenges, moving to computation closer. Like basically with edge computing, it'll be like I'm taking cloud home. So basically, when there is detection, it won't have to start first to cloud, because usually with cloud we'll need a high bandwidth. So with edge computing, everything will run locally. So it will be easier for the farmer to a prompt alert if there's any abnormalities in the cattle. Also the methodology stages, the research stages, the literature, the design science, and the model development. And also at the end, we'll do the evaluation. Basically, this is the picture that I got, but it's an overview of what I'm trying to achieve at the end of the day. The architecture design, I got it from the IoT approach, the IoT sensor approach. So what I'm going to do is to, let me just move to the next slide. The architecture design, where I'm going to now integrate this edge. So basically, we'll start with body areas, and after that, we'll do the data processing layer, and also do the deep learning, where we'll train our models, basically the sensors, cameras, basically on the existing models that are there. And also now the edge computing is where it comes in now to detect, to they say to check, basically, or to sum up everything in order to have that and edge computing that will apply to the livestock health monitoring model in the rural areas in South Africa. And also the extend the research on multi-sensors fusion in livestock monitoring. The contribution to practice and society is to, as farmer intervention, is with farmers intervention is to enable the proactive disease management by detecting illness day before symptoms are visible. So it will be easier for them to know if the cattle is sick, allow them to isolate or treat that cattle earlier, and reducing also the antibiotics use and increasing recovery rate because of the mortality. Yes. And also the economic impact, it will also help mitigate the mass finance losses associated with the disease outbreak in the rurals. Animal welfare, it will provide better animal welfare by ensuring timely veterinary care, based on objectives, continuous health data, and moving away from reactive management. In conclusion, is that the aim is to bridge the gap between technological advancement and the real world application by designing an edge AI cattle health detection model that will merge deep learning, body area sensors, and edge computing for early disease detection, and also address the real challenges faced by the rural farmers in contributing to a smarter and more sustainable livestock environment. I thank you.
Thank you very much. Another round of applause for Mr. Mashango. Inspiring and well-delivered presentation on early behavioral cattle health detection model using deep learning and body area sensors. Colleagues, we will now take questions. I'm not sure if this is intentional or. Okay, let's move.
Let me thank you. No, thank you for the great presentation. Your research is very interesting. I will start with, I'm just advising, I will start with the topic, the title, Early Behavioral Cattle Health Detection Model Using Deep Learning. So rather cut out the body area sensors. Rather explain that you'll be adding sensors in the abstract or in the methodology. So that part of body area sensors, you don't have to mention there. The title, without that, it's straightforward. So the difference will show inside when you're explaining how your model will be different when you're explaining the gaps in your body of the article. That's my advice to you. And then also, I would advise you to add in your content, add where the sensors that you're mentioning, where will those sensors be located and what data will they be capturing? Like cows at the moment are suffering from delivering their babies naturally. The farmer has to intervene and pull out the fetus inside because they suffer from suffocation. Others are coming out facing backwards. So those are the kind of issues that they are facing. So that's another aspect that you could look at. We're having a sensor inside whereby it will actually assist the farmer to know that this cow will be able to give a normal birth naturally without assistance from a human being, or I need to intervene. Because at the moment, if you can check in line, I'm following a farmer who has a lot of sheep. So she's having a problem whereby she has to pull out the fetuses, and you find out because she's too late, a sheep has lost all the babies, like 3. So please look into that. Thank you.
Thank you for the comment and recommendation.
Yeah, thank you for the presentation. My observations are a bit similar to what the last speaker just said. The methodology really need to work on it. The body area sensor is not well explained at all. Then the data you want to use, what's the sensors you mentioned, what are they measuring? The body area sensors, are they measuring the temperature? You never mentioned anything like that. So mention specifically what are those data. Then tell us about the statistics in your methodology, the performance metrics, then the deep learning models you want to use. You have to also mention them. Thank you.
Thank you.
Also, in addition to what my doctor friend has just said, before it becomes too
Colleagues,
bulky.
sorry about that. I just want to remind our audience that we should try to be brief in asking questions. Thank you.
Before it becomes too bulky for you to work on, I want to talk on your references style. Can you just tell us this reference style that you use? Maybe that will help me to.
EndNote.
Your reference style. What
We're using
style did you?
EndNote, but
If you go back now, you will see that they are not consistent. You are not consistent in using them. Before they would become too bulky for you to make them consistent, try to stick to an actual one that you want to use. Because the one I saw here, they are not consistent at all. Your reference style. If you want to use for the upper, let it be upper. If you want to use for MLA, let it be MLA. They are not consistent. Thank you.
Thank you. Okay, thank you, Mr. Mahlangu. Mine is more of curiosity, but I think it can build towards your foundation so that your study can stand solid. I need to know why cattle, why not human being, why not cows and all of that? Why specifically cattle? And maybe if it can be built up towards a background to say, maybe in the literature to say, this was not, it was oversight, it was not being studied thoroughly and all of that. That was my question. Thank you.
Just a quick one. Mine is just to tell you that hold your head up. It's a very, very relevant topic. And I can see that this topic will go far. And so that's just mine. Hold your head up. Thank you very much.
Colleagues, Dr. Mieti, would you like to go first? We have an audience online who would like to ask questions.
No, I think Doctor actually took my words because, you know, if you check where the study is, most of you, because you're researchers, you know, research evolves. You know, at the end of your research, maybe even this topic is going to change. But I mean, where it is and the work that you've done for me, and it's relevant to what we are doing, you know, in the faculty. For heads up again. Thank you. Thank you.
Thank you very much. Would you like to respond to the contribution? Okay. Okay. Please remain here. I would like to take the questions from online. Please go ahead and ask.
Hi, colleagues. I don't know if I'm audible.
You are audible. Thank you.
Okay, thanks. So I'm particular about what the researcher has to find is not clear. If you create a model to detect animal health, then somewhere in the experimentation, we need to see what the researcher would measure and the performance of such a model. So if you have 5 cattle and the model detects one of them being 5 sick cows, but the model detects only one that's sick. So the researcher should actually think about actually underpinning the measuring of the animal health detection. But if that's not the problem he's trying to solve, then this question would be irrelevant to the research. Also, what is reported out there in literature on detection of animal health using machine learning models, which he also mentioned it's going to be XCNN, it's going to be vision transformers or whatever. But what is reported out there and what is the problem that exists in the current research that detects these. So I see he's shared the background. So what is the performance of this model and what is the problem that you address with the performance of these models in animal health detection? Thank you.
Thank you for the question. First, I think let me answer with let me start with the second question. I just didn't mention them in the models because usually they are more effective in extracting features from complex time or getting to classify diseases in animals. So we'll use CNN and RNN to on the model to simulate or to detect basically the sickness in the cattle. And two, why? Okay, what is the problem or the gap with the previous ones? The previous researchers is that they only work independently in these technologies. So my research now is to unify all these technologies and also to assist the rural farmers in order to cooperate this model with low bandwidth, low latency, and real-time response. Yeah, thank you.
Thank you very much.
You may not make it a conversation, but please specify to measure accuracy, mineral precision, or any of those metrics, really. But it should come out in your literature review that these authors have measured accuracy. It doesn't work correctly. Or whatever the case is, but the metrics you measure must come out in your method to say our measure accuracy to detect sick entry. Then when you find, then you know that you can find what's the accuracy of this model to detect sick entry. Because because what I'm going to report on at the end, if you don't mention it up front, that's what I'm trying to say. Okay, thanks.
Okay, thank you. No, I'll work on them then. Thank you, sir.
Thank you very much, colleagues. Mr. Mahlangu, if you do not mind, just remain here. I saw that we have another question from the floor. I'm looking at the time. We still have 3 minutes to accommodate that. So don't worry, there is a growth in being critiqued. So this is for your benefit. Okay, any roaming mic so that colleague can ask a question.
Oh, why kettles? Is okay.
Okay, I do not see a member with a roaming mic, but I would allow.
Thank you, Derek. Mine is not a question. It's just some submission to you. Your presentation, like what other speakers have outlined, is very interesting. And I may say that I'm proud because what you've presented is not a full research. You are still on the proposal stage. You have done enough up so far, which it outlined that you are getting
better and better each and every time when you conduct your literature. Therefore, keep it up. You're still gonna adjust and change a lot of things when you find new technologies, even new parameters that you may use in order to measure in order to detect the diseases on the cattle. And remember, your model can also work on another animals, not only in cattle. Therefore, keep it up. You're doing good. Thank you.
Thank you very much, colleagues. It is now 11:59. We will thank you, Mr. Mashangu. You can be seated. A round of applause. Okay, colleagues, we will now move to viewing of poster session. This will take us an hour from 12 to 1. There are a few amendments on the program. Lunch will now be served at 1. And an announcement to the poster judges. Please collect the score sheet where breakfast was served. And we are going to have lunch the same area. May I request that after lunch we gather in the same venue at 13:50 so that we can continue with the program. Thank you very much.
This is a pattern I've seen throughout events over. Having lunch before the other candidate presentation, you'll have less audience in the venue because after they have lunch, some of them come. So is it possible for us to push the other three that we still have, the other two we still have, and then that's my suggestion. That's my suggestion.
Okay, thank you very much for that suggestion. We do believe that the audience in the venue will honor the time and remain until the end of the event. Unfortunately, that's how the program has been designed. We are going to follow it as such. Thank you.
Thank you for your presentation.
No, I haven't presented yet. Oh, you leaving now? Yes. Yeah. I'm still presenting it. Oh, no, not yet. All right, thanks. Sorry, I hope so.
I didn't think you could be the keynote.
Yeah, you know,
Because I get up to detail.
I will definitely do it. Yeah, so this is the presentation because the one link is in the made updates.
Did you send me an update? Did you send me an update?
Yeah, okay, what's your name?
Matabali.
Oh, Tumen.
Yeah.
Oh, I'm willing to send you. Oh.
No, did you send it yesterday?
No, I didn't send it yesterday. Oh.
Let me look for a drive. Do you have a USB?
No, I don't. The thing is, I can't use USB now. Look, I can't use USB on this laptop.
Okay.
Let me send you the.
For posters, which category are you reviewing? Oral. You're only doing oral. Only oral. Yeah. Thanks, Dr. Ramak.
So can I send it via email?
I'm gonna get it right. Can I get that used?
Oh, you want to? No, just say the interest of those who are online. No, I can't use this. Use your web I can't use this. So, like I said, I can't. The USB is blocked. Yeah. Oh, the USB is blocked. Yes, the USB is blocked. Yes. So I can't use USB.
Marwan, maybe you can use your laptop. Let's see.
Because they said those who are online, they
Oh,
won't be able to
yeah.
see. Yeah. Because I was going to use my laptop.
Yeah, send me an email.
No, let's see. These two. They're not only.
Why is it no flop over there? And how is it?
It's a lot.
So I think what's gonna happen if the judge is
Yeah, I did send it, man. Yeah, just now, yeah.
Thanks, Doc. Mano, me Jani. Yes, I was like, yeah. I wasn't so bad. No, thanks. I still like my friend. But I'm also dependent. Yeah.
Dank je, dokter Etienne.
Ngwana somara no o tswere phone ne. Sorry.
Kelvin, can you hear me?